Hi, my name is Mary Newsome. I'm an associate professor here at the University of Utah within the Department of Neurology, specifically in a center called the Traumatic Brain Injury and Concussion Center. And I've read a lot of articles in my life, and so I'm here to hopefully help you if you have a little bit less experience than I do. So let's go ahead and share with ourselves here, so I can get the PowerPoint up. And here we go. Alrighty. So yes, this is the beginning of the little lecture here. Um, and I wanted to, because everybody who's looking at this probably is if you're not already pretty familiar with Enigma, I'm sure you will become familiar with it. But I thought just to help you become a little familiar with it, I would go over a particular type of paper called a review paper to help you in that process. So we can do a couple things at one time here. There are a few different kinds of papers or scientific articles that I'll talk about in this presentation. But here's a review paper to start out with. Um, so here we're talking about a large scale study. And well, large scale studies, it's a review paper. So they're going to be talking about more than one study and across 40 countries. Now, this was published in 2020, and chances are that there are, I don't know how, maybe there's 30 or 40 um, more. Well, I was going to say working groups, but I haven't really introduced that yet. But it may be the case that this is a little bit of a the and these studies come from more than 40 countries potentially, but these days. Anyway, sorry, it's been a long day. But let's get into the background. Any article that you look at there's going to be a background or an introduction in the beginning of it. And in this paper, Dr. Thompson, the founder of Enigma, is simply like giving the background on Enigma, like telling us that how it started. So here we understand that there was mostly very small studies in the beginning when people started looking at genes and and traits, and then these effects, because they were so small, maybe a few to hundreds of participants, that these effects didn't always replicate. And as it turned out, they were pretty small effects. So thus began the inspiration for Enigma to be able to put together multiple data sets from across the world, around the world, to get more signal, to be able to detect better power, get more signal out of all the data. And this is just a little example of this is a part of table one in Dr. Thompson's review article. And I just wanted to mention that any kind of review article will have some sort of table like this, where it's going to vary based on the kind of review article that it is, but it might mention, you know, a particular paper that it's looking at, and the participants that were involved, their age, or whatever's relevant. If years of education is relevant to the review, they'll put that in the table. And here's, a nice little section of main findings. And for example, we can just kind of go, there's a substance use disorder group, and they found that um, some regions of the brain had reduced volume, and also reduced thickness. And one of these areas, one is called the insula, another one is the medial orbital frontal area. And these are important areas. So unfortunately, people with these disorders might have reduction in some of the functions that these areas do. For example, medial orbital frontal cortex, that can be involved, I guess, in decision making, as we'll see. So I'm going to next talk about more of an empirical study from Enigma. And sometimes, like when you submit a research article to a journal. They'll have different categories, and a lot of times they'll call this kind of study original research. Um, and in this kind of paper, again, there'll be a background section, and there'll always be a methods and a results section and a discussion section. And at the very beginning is a very brief summary of all of these sections. It's called an abstract. And that's what's going to be, I think, like, maybe a number one resource for you whenever you go to read an article is check out the abstract first, because that'll break everything down very briefly, and you'll get a good, a good place to start from to understand. Um, so after the abstract, which I think could be potentially be a good topic or a title for a book or something. I'm not sure. Maybe it's just too blasé, but maybe it could be good. But so after the abstract, we will see again that background, which is really critical to understand, like, why was this study ran? Like, what's the point of it? It'll have a brief discussion of other studies that are related to it, but also um, while describing it, it'll point out what's missing. Um, and they'll sort of be, I'm not going to say mind the gap. I'm sorry, no. And so it'll show like what needs to be studied. And oh, look, our study does this. And so when describing it, and after that, they can, in this background at the end of it, talks about like exactly what the hypotheses of the study are, hypothesis or hypotheses. After that, the background is the methods. This is a very detailed description of the way that the hypothesis was investigated. Um, and then the results section, and part of it could be descriptive, basically like describing the means and standard deviations of the ages in the study of the people in the study. Maybe there's probably going to be more than one group. Often there's a patient group, a group of people who have, let's say, brain injury, and then another group of people that might be all the same age and generally the same amount of education, level of education, that we're going to be comparing the brain injured people to. And so here you might see, a table that shows like, okay, well, these groups, they weren't statistically different from each other, or maybe they were statistically different from each other. But that's the kind of one thing that you might see in the results. And the rest of the results are going to perhaps not be descriptive, but they'll be talking about statistical analysis that was performed, the results of statistical analysis that was performed to look at these for group differences, if that's what the paper is about. And then there's a discussion that it ends with that might start with the first sentence or two might just be a brief summary of the results. Then it'll go into like how these results relate to other studies. Did they replicate some things that other studies did? Do they show something completely different? And then you can then you'll read like all suggestions as to why they might be different. And then, people might suggest, well, they always, yes, we do suggest potential future studies. And then there's a section usually that on the limitations of the study and the strengths of the study. And I said the discussion was the very last, but there's really a small like paragraph that comes at the very end of many articles called conclusions. And that also is a nice place for a summary. So I'm going to mention in a second, but one way to start out when you're reading your article is to look at the abstract and then look at the conclusions and just kind of like build on your knowledge from there. Because the conclusions might say something a little bit different than the abstract. It won't have the methods in it or anything, but it'll have like a nice description of the findings. Very brief. Um, so let's go. So basically, there's a different approaches for how to read an article. One might be to begin with like skimming the abstract, skimming, and then looking at which includes looking at the abstract first. And then after you maybe have a good understanding from the abstract, that you might decide where you want to go next. You could head right into the introduction to understand the motivation behind this study. Or you can go straight to the results section to kind of get a feel like, oh, so what did they find? And then backtrack to the introduction. But the intro is one good place to start because it'll tell you, the reasons why the study was conducted and the motivation behind it and the hypotheses that guided it. Um, but I'll mention too that along with the abstract, if you do want to pop into the results section, that might give you a quick idea of the results if the tables and figures are clear to you. And if they're not, we'll get you to that point. And then again, skimming the discussion is also like another step there. If you want to when you're skimming the methods, there's a few things that you can look for. One is this, it's often table one, it's the descriptives of the participants and their characteristics. Well, the descriptives of the participants. And like it'll say how many participants there were. And some of you may know about the law of large numbers. We just talked about Enigma. And how important it is to be able to have large sample sizes because that's going to be more representative of the population. So if you happen to notice that sample sizes are kind of small, think about like, well, is that weakness addressed in the discussion and what does it mean? Other things you can look for in the methods per se are the dependent variables, the independent variables. How were the dependent variables defined? Like, what does it mean to have brain injury? Like there is usually inclusion criteria for the study and exclusion criteria for the study. So those will define the dependent variables if they're groups, patient groups. And how are the independent variables measured? What kind of statistics did they do? Was there a correction for multiple comparisons? Things like this you could be on the outlook for or the lookout for. Um, but yeah, but you don't have to think about it when you're skimming. Maybe I'm just kind of blathering a little too much here, but you don't, when you're skimming, just kind of try to get the general information about the study. These are questions though that you can go back later and think about where the sample's small or whatever. Whatever could be a limitation. And it would be interesting if you could find limitations that the authors didn't point out. I mean, that's a legit thing to look at. And then is there anything about the methods that could have biased the results? An example of this might be, if it's a paper that's reporting a randomized clinical trial, RCT, a lot of times, let's say, somebody's looking at the effect of meditation on anxiety. Okay, so maybe, if you usually what happens is that people get in they'll get randomized. The people with the anxiety disorders will get randomized into either the treatment group or the placebo group or whatever the comparison group's going to be. Maybe so if meditation's the treatment, maybe it's not going to be maybe it'll be something like an education kind of group where people learn about, I don't know, how to deal with anxiety or what anxiety symptoms are. It's not a complete waste of their time. They're getting something out of it, but it's not the actual intervention itself. Other kinds of comparisons might be like treatment as usual. Like, well, maybe some people are on getting medication, maybe they see a psychologist once a week or something. So you can just compare the people who get this intervention, say it's meditation, to people that are in a treatment as usual group. But the thing that could maybe bias results is if you don't have randomization. So like treatment as usual group won't be randomized. Well, I mean, could it? Yeah, it could be. But let's say, for example, that everybody people can sign up for whatever group they want. Then it might be the case that the people who sign up for the meditation group, maybe they're the people that have the most anxiety. And so in that way, the groups wouldn't be similar. And the groups have to be similar as much as possible, except for the treatment condition. So see if you can, when you go back over it again later, if you can point out any biases in the methods. So After you have a general feel for the paper, read it again more comprehensively and in more detail. And I mentioned original research articles before, I think. So here's the Enigma one that I mentioned earlier. So this was a big study looking at the effects of schizophrenia and brain aging, looking at whether people with schizophrenia have like maybe an advanced brain age. Does schizophrenia age your brain more? And you can see, like, yeah, I mean, right away you can tell that this is going to be from not only in the title, it says 26 cohorts, but just from the number of authors, you can see that it's from a lot of institutions. And then just like just kind of scanning this abstract, they talk about how many subjects there were, and that's a very, very sizable number of people with schizophrenia, and in their comparison group, healthy control people, they're the same age, roughly 30, 4-ish. I mean, that's very, very close. And same range, 18 to 72, 18 to 73, roughly the same amount of males in both groups, males and females. Um, okay, so, and what they found was that looking at this age difference, that people with schizophrenia had a higher predicted age difference of 3.5 years approximately. And that wasn't really associated with anything. Like, they tried to see if maybe how old they were when they first experienced schizophrenia. Does that influence like how their brains age? How long they've had it, how severe they have it, or their type of medication, but really nothing was associated with with no specific clinical characteristics were associated with the brain age. So this is just a type of original research or empirical research study. Other kinds involve reviews. Two main kinds of review articles are meta-analysis and systematic reviews. And I'm trying to guess a lot of information on this one slide here. But if we look in the lower right corner, these are just definitions of what these things are. Meta-analyses, you try to statistically, you look at a number of articles that all look at similar things, like let's say the effect of eating cereal on depression or something like that. And so if you can find enough articles that have that, you can take their results and then analyze them all together and see if there's a bottom line group finding or a bottom line finding for the relationship between the variables. Systematic reviews don't really involve that kind of statistical manipulation. They're more a review of like the findings of studies that are looking at similar topics. Usually, it's looking at the effect of hello, that's me again. Okay. Um, Looking at the effect of a treatment on a disease, for example. And then the best kind of systematic review is an umbrella systematic review, because those are it's the analysis of multiple systematic reviews which are great in and of themselves. So because confidence is pretty high for umbrella systematic reviews, their findings, because of a large number of studies that are looked at, their findings can sometimes guide health policy and clinical care. So I just thought I would show you an example here of a umbrella systematic review that I kind of liked the outcome of. And probably a lot of people who drink coffee might like it. So basically, this was one of those giant systematic reviews, and they found that coffee is protective against dementia and Parkinson's disease. I think they had larger effects for the Mediterranean diet on a number of other things, but this still counts. Okay, let's see here. And then the last thing are case studies. So I'm going to talk about our case studies. And case studies are basically kind of like what it sounds like, or case report, that so you're looking at one case or maybe one person, one particular kind of patient, or maybe a few of them, a case series. We look at several cases. But so it could be like maybe a physician is treating a patient, and they notice like this, maybe unknown or not common effect of the disease that they think is related to the disease. So they write up a case report. And this I thought was an interesting kind of condition. And it looks like we probably won't be having any Enigma groups on it soon because like it's really kind of rare. But I'll just pretend that it's pronounced aphonogelia. And it's basically the inability to laugh out loud, which would be horrible. I mean, it's like, the probably the, maybe that's not a bad thing to have, but laughing out loud is kind of a fun thing to do. So anyway, this 16-year-old girl, after a severe traumatic brain injury, just found she couldn't laugh out loud anymore. And I kind of want to point this out too. So in this abstract, they report the level of evidence. And that's kind of a little guideline, and they say it's level 5. So let me talk a little bit about just spend 2 slides worth on the kind of ratings that articles get. The American Academy of Neurology has 4 ways of classifying the quality of the evidence in an article. In other words, the risk of bias. And you can see that class 1 is the best kind of article, and class 4, maybe not put so much reliance on. To guide clinical practice, I think this is what the aphonogelia, is that what it was? Paper was graded itself on. So here you have levels of from 1 to 5, and it's really the case that, yeah, like with case studies, they're interesting. They might, help people understand a disorder more. They might, um, I don't know, give a physician a sense of, yeah, I guess just I'm not a physician, but I can see how they could be interesting. Well, I know for research, for example, if you find somebody with traumatic brain injury that has that, and then later on, maybe you're interviewing a patient, and they seem to have it. Like that's sort of an interesting thing because I think one thing about that disorder was that there's really not that many people who have it, and I think that you don't have to have traumatic brain injury to get it. So it's pretty rare, and it just maybe gives you an idea of something to look more into, case studies, that is. So anyway, for this level of 5 evidence, you can see like it's not really going to be guiding any clinical practice anytime soon. It's just going to be based on, one subject, one participant, one patient, and that's not very generalizable. Okay. So here, this is just below. I'm going to share with you, if you get the slides, there's some links there about other people's approaches to reading articles. But the last slide I'll have for you is just to say that, there chances are you might come across some jargon that's not clear, that's not defined in an article, and especially if you're just starting to read them. So you might want to use AI to help your understanding. Maybe you're having trouble interpreting a graph. It can be totally useful, and it'll after you skim it, and you find something that you don't understand, you know, check it out. But use it to complement your understanding rather than as the basis for it, because it's going to be much more meaningful to you if you actually go through it yourself and build all these representations for what you're reading. So these are just some additional sources to check out. And I mean, feel free if you have any questions. I'm going to guess there won't be too many burning questions about how to read an article, but if you have any, please do feel free to email me. I'm happy to help. So thanks for listening to this little presentation, and hope you have a good day. Bye.